Good afternoon, everybody. My name is Don Johnson, and we're at the Clemson University ICAR Center. And today we will be dissecting a pin tumbler lock. And the group's 7 members include
Sunman Ko, Chillin Ju.
In this video, we will determine how the lock operates. We will just also determine how we would redesign the lock so the lock to make it easier to manufacture and assemble. We also determine how we would open the lock without damaging it, without a key. Also, we will evaluate the device and explain its strengths and weaknesses. Finally, we'll have suggestions, changes to the design of the lock. In 1861, Linus Yale Jr. patented the pin tumbler lock, which remains in use today.
Is a fully assembled pin tumbler lock. In this frame, you can see the lock being disassembled from the door. First, we have the lock screws, the actuator screws, the housing cone, the cylinder, and finally the bolt. In this frame, we see the cylinder, and the cylinder is the outer piece of the lock that houses the upper pin chamber. As the pin cover is removed, exposing the springs, the cylinder, and the plug, you can see the pins as well. Right now, I want to break down each portion of the lock and kind of explain what it does. First, we have our tumblers, and the tumblers are the key pins that are touched by the keys, and they are sized differently, corresponding to the different depths it cut in the key. And when the correct key is inserted, all the key pins will be aligned, and it will create what is called a shear line, allowing the plug to rotate. Next, we have the pins, and the pins are placed between the tumblers and the springs, and in their resting position, the pins block the rotation of the plug. The plug is the inner piece of the lock that rotates upon insertion and tension of the correct key. The plug is connected to the cam to actuate the bolt mechanism when rotated. The cam is an extension connected to the back of the plug, which actuates the bolt mechanism to lock and or unlock the door. In the frame, we see the plug and the cam being extended, the fork-shaped end of the plug. We see the key, and we see the tumblers that sit on top of the key. We also see the C-clip or C-clamp that helps lock the plug into place. Is the locking bolt, and it actually locks out of the door into the wall, and also the lever that actually keeps the bolt locked in place. Fully disassembled the pin tumbler lock. Now in this frame, we can see the reassembling of the plug, the cam, the tumblers, and the C-clamp. We have the reassembling of the plug back into the cylinder, the C-clamp, the pins going into the cylinder and the springs, and finally the cover being administered. In this frame, we have the fully assembled pin tumbler lock being reinserted back in the door, starting with the bolt, locking bolt, the cone, housing cones, the cylinder, and the screws. In this slide, we kind of wanted to show some of the design features of the pin tumbler lock, which makes it a pretty remarkable design. see the key being inserted into the plug, and how the pins are kind of sloped or machined to have a slope, so the metal slides clearly back and forth over the pins. The strength and the design of the pin tumbler lock, we believe, is this lever and the groove that is cut to hold the bolt in place and locked, and it can't be moved. The slope of the cut in the lever holds the pin in place from being able to move back when it is locked. This project, we were asked to determine a few questions, and one was to determine how we would open the lock without damaging it if we didn't have the key. Two, to determine how we redesign the lock to make it easier for manufacturer and assemble, and to evaluate its strengths and weaknesses. First, we'd like to explain how to open the lock without a key and without damaging it, and that would be by picking the lock. That consists of a pressure wrench to slide in, holding the pins down, and sliding a paper clip or a picking tool to move the tumblers into position. Next, we wanted to evaluate the strengths and weaknesses of the lock, and my colleagues on Team 7, we discussed this in detail, and we believe that the weaknesses, one was the easiness of picking the lock and getting it open, and also the intricate parts, the number of parts that were inside the lock that made it difficult to reassemble. We believe the strengths, one was the simplistic design that has stood the test of time and that hasn't too much varied from the 1800s after it had been patented all the way up to today's locks. After discussion of the weaknesses of the lock, we came up with several ideas how to redesign the lock. And one was to have a cross-shaped key, and this would alleviate the problem of picking the lock, which is fairly simple. This would entail pins on each section, 4 corners of the lock, and that would eliminate one person to being able to pick the lock. We also discussed the material of the pins, which is copper, which is a soft metal, and we believe by making the pins titanium, stronger metal, this would reinforce the lock a little bit better than the copper. Also, we suggested that we make the springs a little bit stronger. They're rather flexible, and make them a little bit stiffer so you can't slide a picking tool up and move the tumblers. This concludes our presentation from Team 7. Thank you for your time and your patience.